Hello viewers, welcome to the lecture. Today we are going to see about the historical background of finite element methods. So before into the history of finite element, we must know about the meaning of the finite element. So finite element is one of the analysis technique in which a structure is divided into number of elements and then they are further analyzed to a finite level. So it is one of the key uh, tool for engineering problems. So in 1908, the first mathematical foundation is Ritz method. So they invented by Walter Ritz, and in 1915 its Gallerican approach. So there are a few early pioneers. They are Alexander Hrenoff in 1941 and Richard Courant in 1943. Alexander Hrenoff discovered about the solving elasticity problems, and Richard Courant did about the piecewise polynomial interpolation over triangular subregions. And in the breakthrough is from the academic year 1956, where Boeing, Turner and the Boeing team, they invented few methods that we are using nowadays. They are nothing but our direct stiffness method, stiffness matrix approach, and so on. So this is the key factor, because the finite element is, as I told earlier, this is a subject which deals about the analysis of structures in detail. So here for a aircraft structure, we must analyze all the structures and their properties, because a minor failure or a minor error can cause fatal injuries. So in Boeing, the aerospace team, they used finite element methods such as direct stiffness method and stiffness matrix approach that we even use today in FEM. So they are the breakthrough in the year 1956. So and in the year 1960, a mathematician whose name is Ray Clough, who proposed the dividing continuous domains into finite pieces to solve complex engineering problem. So there are some key contributors. They are John Argyris. So he developed the energy theorems and matrix methods. And the next key contributor is Algerd Zinquist. So he extended FEM to broader field problems. And the third person is Bruce Irons. So he invented the frontal solution method and isoparametric element. So they are the key contributors of the finite element methods. So in the year 1962 and 1972, this decade is called the golden age of the finite element. Why? Because the element library expansion, the convergence theory, the nonlinear capabilities, and commercial softwares are all developed during this period. So till date, there were nearly 1,000 plus research papers published. That means during the decade in between 1962 to 1972, if we see there, around 1,000 plus articles or research papers has been published, and they also developed 50 plus element types for various applications over engineering. So this is the highlight of the golden age. And from this presentation, let us conclude by discussing this mind map. If you see this mind map, you can see here first mathematical foundation, that is Rayleigh-Ritz method, Gallerican method, invented in the early 1900s, and pre-FEM structural ideas, that is stress or energy methods. Then Hendrikhoff Courant 1940s, and aerospace development around 1950s, and Clough naming of the finite element method in 1960s, and later in 1960s the expansion happened, and in the 1970s the mathematical approximations are used, and nowadays we use modern softwares for solving the uh, structural or any analysis that is required for the engineering problems. So this is about the history of the finite element, and you can see here. So this is a final slide for the presentation, and you can see here 1970 the theory meets practice, that is Gilbert and George Fix, who published their 19 work in the year 1973, that is the analysis of finite element method, right? So they provided a comprehensive mathematical theory for the convergence and error analysis. So now the finite element methods is a technique which uses multi-physics, biomechanics, AI integration, and advanced materials. So this is what the things that are incorporated in the finite element nowadays. And in the modern era, if you see, the AI's domination is keep on increasing. So this is one of the key aspect of the key technique or the tool that is used in the engineering and to solve complex problems. So that's it about the lecture, and let us meet in another lecture. Thank you.